Good afternoon, everyone. In class on Friday near the end, I had mentioned that I would put together a video going over the quiz that we wrote on Friday. The questions that I'm going to do here may or may not line up with the exact questions that you had on your version of the quiz, but the ideas are the same. So the first question on the quiz gave you a point that lies on the terminal arm of a rotation angle, and you were told to find the exact value of each of the following. That word exact is important. We'll get to why it's important in a minute. But the first thing you're asked to do is find the value of r. Now, x squared plus y squared is equal to r squared. This is a fairly basic calculation because you're told what x is. The x coordinate is -3. You're told what y is. The y coordinate is 7. So it's really just a matter of you putting x squared plus y squared into your calculator to find out the value of r squared. Once again, I mentioned this Friday. I mentioned it numerous times in class. When you square a negative number, if you're going to rely on your calculator to square it, you have to put it in brackets. So we're going to put -3 quantity squared into our calculator. Quantity squared means we're squaring the entire -3. We're not just squaring the 3. Plus, well, you don't really need brackets around the 7 because it's a positive number. But if you just remember to put brackets around anything that you're squaring, then you will never make a mistake in terms of negatives or positives. So we hit equals, we get 58. Now, if you try to take the square root of 58 on your calculator, you're going to get this long decimal. And anytime that happens, that's telling you that the number you were trying to take the square root of is not a perfect square. And what that's telling you is the square root of that number, in this case root 58, is what we call an irrational number. There's no way to write it as an exact value in decimal form or in fractional form. And what that means is that in order for you to record your answer as what the value of r is, you just record root 58. That's the answer. When you take a look at sine of theta, well, sine of theta is y over r. When you look on the right-hand side of the screen here, sine of theta is y over r. We know what y is. Y is 7. We've determined that r is root 58, so y over r would be 7 over root 58. You're also asked to determine what cosine of theta is. Well, cosine of theta on the coordinate grid is defined as x over r. Well, we know what x is. X is the -3, and we've determined what r is. It's root 58, so cosine is -3 over root 58. Tangent, of course, is y over x, and we know both y and x when we look up at the top of the screen. Y is 7, x is -3, so tangent of theta is 7 over -3. Now, I typically wouldn't write 7 over -3. What I probably would have written is -7 over 3. That doesn't mean that the y coordinate is -7 and the x coordinate is 3. It just means the ratio of the two is a negative number. We very rarely see a negative written in the denominator. So that's question 1. Take a look at question 2. You're asked to find the cosine of a rotation angle and the sine of a rotation angle. And in this case, you're not given the coordinates of the point. What you're given instead is the tangent ratio. You're told the tangent of the rotation angle is the ratio of 8 over 15. And you are told that the terminal arm of that rotation angle lies in quadrant 3. That's not an unimportant piece of information. That's an important piece of information to know. And the reason why it's important is when you take a look at quadrant 3 is a location on the coordinate grid where both x and y are negative. When you look at your definition of tangent, I'll just highlight it for you in blue so you know what I'm referring to here. When you look at your definition of tangent, tangent is the ratio of y over x. And up at the top in the question, you were told tangent of theta is 8 over 15. So you might believe that that means y is 8 and x is 15. because y over x is tangent, and tangent is 8 over 15. That makes sense. Except that in quadrant 3, both x and y are negative. So in reality, y is negative 8, and x is negative 15. We don't see those negatives in the tangent ratio statement because when you divide two negatives, the negatives cancel. But we still have to be aware that both of those values of y and x are negative. So now I can write in x equals negative 15. I'm looking at the bottom of my screen here. Y is equal to negative 8. Now I can determine the value of r. So again, I'm going to use for this step x squared plus y squared is equal to r squared. Don't forget to put the brackets, negative 15 quantity squared, that means in brackets squared, plus negative 8 quantity squared. Now, to be perfectly frank with you, if I were entering this on my own and I were not explaining this to you, I wouldn't have put the negatives in at all. And I wouldn't have used brackets. Because I know that when I square a negative number, the negative is going to go away. Regardless, this is one of the rare cases in this course where I would say, you know what, I really don't care what you do on your calculator as long as you were able to determine that r squared is 289. I don't care how you get that. Now in the previous question, number 1, r squared was 58, and you can even see that when we took the square root of 58, we got this 7.615773,106, and that told us that there were essentially an infinite number of decimals after that, and we couldn't record the exact value in decimal form. If I try to take the square root of 289, I discover something interesting, that it is exactly equal to 17. So I don't need to write it as root 289. I can just write r equals 17. And now, in order for me to determine the cosine of the theta, which is this first question A, cosine of theta is found by taking x over r. Well, we know x is 15 and r is 17, so cosine of theta is negative 15 over 17. We're asked to find the sine of theta as well. Sine of theta is y over r. Well, we know y is negative 8 and r is 17, so sine of theta is negative 8 over 17. And that's question number 2. All right, and that leaves question 3. In question 3, you were given a statement that a trigonometric ratio had a certain value. In this case, in the example I'm showing you, sine of theta is equal to negative 0.4183. You're told that theta has to be an angle between 0 and 360 degrees, and it could be equal to 0 degrees, although it's not going to be. You're also told that there are 2 solutions. Now, by the time we get to our exam, which will be on Tuesday, I would not give you this statement. You're expected to know how to figure out how many solutions there are going to be. And it has to do with whether the trigonometric ratio that you're working with is positive or negative. In this particular case, you're told sine of theta is equal to a negative number. Now, if you take a look at the definition of sine of theta is equal to y over r. And it's very important that you see this negative here. Sine of theta is a negative number. Well, the only way that sine of theta can be a negative number, since r is always positive, is if y is negative. So what we're doing at this point in time is we're figuring out that wherever the rotation angle lands, it can either be in quadrant 3, where y is negative, or quadrant 4, where y is negative. And that's going to lead us to our 2 solutions. So now let's walk away from that for a second, and we need to find what's called the reference angle. Now be very careful here. What we're going to find on the calculator, which is called the reference angle, is not theta in the question. Theta in the question, which is what we are trying to find, this theta, which is this theta, and it's this theta, that is not the reference angle. What that is the rotation angle. So what we're about to do right now down here, and it's going to be done on our calculator, is to determine the reference angle, which is not the answer to the question. So to find a reference angle on your calculator, you use the second trigonometric function ratio. So you go second sine in this case. And you're going to enter the value of the trigonometric ratio, but you're not going to put the negative number in. You're simply going to put, in this case, 0.4183. And I mentioned in class before, if you do put the negative in, then you have a different path to follow if it's sine of theta. And if it's cosine of theta and you put a negative in, you've got a second different path to follow. And if it's tangent, you have a third path to follow. So rather than having three different sets of rules that you've got to try to wrap your head around, we have one. To find the reference angle, you ignore any negatives. Make sure your calculator is in degrees, and I get a reference angle of 24.7 degrees. So I'm just going to put that up here where we can see it. Now, what does that mean? It means that the terminal arm is going to be lying in quadrant 3 or 4. And if it's in quadrant 3, it will have a reference angle of 24.7 degrees. That means that the angle between the x-axis and the terminal arm will be 24.7 degrees. If it lies in quadrant 4, the same thing. It will have a reference angle of 24.7 degrees. Keep in mind both of these angles of 24.7 that I've indicated here, what they are just this angle from here to here. It is not a rotation angle. So in order for us to determine the rotation angle, which is what we are asked to find, you have to determine the angle from 0 degrees counterclockwise to that terminal arm. So I'm going to do my best to sketch this. I'm using a mouse. I'm not at a smartboard. But we need to determine this angle. And we need to determine this angle. So on, I believe, the first day of this unit, we learned that this angle over here, the one that's in pink, landing in quadrant 3, would be 180 degrees plus the reference angle, whereas this rotation angle would be 360 degrees minus the reference angle. So if I take 180 and I add the reference angle of 24.7, I get 204.7 degrees. That is one of my answers. If I were to take 360 degrees and subtract the reference angle of 24.7 degrees, then I get 335.3 degrees, which is my second answer to this problem. So that's the solution to number 3. I really hope that those of you that had problems with this quiz or had some questions you didn't get right were able to figure out the answers and get the right answers on your own. But if you weren't, I hope that this video has been helpful. Have a great rest of the weekend, and we will see you tomorrow. Take care.